Alright, so I want to talk a little bit about the homework from 5.4 and do a couple problems here. And so let's see. So here's 5.4, and I want to look at, let's first look at number 2 here. And so on number 2, what do we got? Let's see. Alright, so I caught number 2, and let's bring it over here. And we can paste it here, and so here it is. Okay, so on this one, what do we have? We want to find this indefinite integral, and we can check our result. It says by differentiation. So this is obviously going to be an integration by substitution because it's not one of our 4 types. And so what we're going to do is we're going to let u be equal to the thing on the inside in a sense, which is a 7 minus x to the 6. So 7 minus x to the 6. And then du is going to equal, the 6 is going to come down. I guess it's going to be minus. So minus 6x to the 5th dx. All right, so this integral is equal to, right, so the integral of, and now this piece here is my u. All right, so this piece right here is my u. And then this piece here and here, right, is almost my du. The problem is I don't have a negative sign. So what I can do, though, is move the negative over, so multiply both sides by -1, and I get my then 6x to the 5th dx. Right, so this is my negative du. Right. Remember, I can rewrite this. So if you want, let's rewrite this. So you can rewrite this as 1 over the square root of 7 minus x to the 6 all times 6x to the 5th dx. Right, then this is my negative du, right, and this right here is my u. And so this is equal to then the integral of u to the, now let's write this as a power, right, so it's in the bottom, so minus 1/2. And then this thing was negative du. Right. I can move the minus sign out in front, so this is minus the integral of u to the negative 1/2 du. And I can integrate powers. I just add 1 and divide. So it's minus u negative 1/2 plus 1 divided by negative 1/2 plus 1 all plus c. And that's equal to, I can do the addition, so negative 1/2 plus 1 is positive 1/2. So I get minus u to the 1/2 divided by 1/2 plus c. If you divide by a fraction, multiply by its reciprocal, so I'm going to multiply by 2 over 1, so I get negative 2 u to the 1/2 plus c. Plug back in, so I made a substitution, so plug back in for it, so I get 7 minus x to the 6 here, so I have negative 2 7 minus x to the 6 to the positive 1/2 all plus c. Right, so now that's my answer, and obviously it corresponds to the answer they gave here, but we can check it. The way we can check this is we can take the derivative. So to take the derivative, 1/2 comes down, cancels with the 2. Right, so I get minus 7 minus x squared, or x to the 6. 1/2 minus 1, so minus 1/2. And all times 0 minus 6x to the 5th plus 0. And so what's going to happen? The negatives are going to cancel, and on top I have 6x to the 5th. And on bottom, because this is negative, I get square root of 7 minus x to the 6, all plus 0. Right, so that's exactly what I have here. Right, so it checks. Checks, it's right. Let's look next at number 4. So let's come back over here and take a look at number 4. So here's number 4. So on this one, what do we have? All right, so to integrate this one, this is going to be equal to what? Well, let's see. We have to make a u substitution. So let's let u be equal to x minus 3. I think that'll do it. You really only have one choice. And so then du is equal to dx. And then I can plug in for u. Right, so I have the integral of 6 over u. And then, of course, du is just dx. So I put a du right there with dx. I substitute back in. That's why it's called substitution. And this is equal to, well, if you wanted to make it real clear, you can pull out the 6, since that's the integral 1 over u du, and that's one of my 4 types. All right, so this is equal to 6 times ln absolute value of u plus c. And I re-substitute in for the u, so that's x minus 3, so I have 6 ln absolute value of x minus 3 all plus c. And I'm all done. And the last one I want to look at is number 7. So on number 7, what do we have? All right, so here's number 7. Again, it's not one of my 4 types, so I definitely have to make a u substitution. So u is equal to x to the 5th, because the derivative is almost 7 times x to the 4th, right? It's actually 5 times x to the 4th, but the powers match up, just the coefficients don't, which is fine because you can always move them over, right? So I get 5x to the 4th dx. You can always move them over by just dividing both sides by 5. And so here's my u right there. There's my u. And this x to the 4th dx is right here. And so this is equal to the integral of 7 e to the u du over 5. And I can clean this up. I'll pull out the 7. So here's the 7. Divided by, I'll pull out the 5 on the bottom. And the integral of e to the u du. That's obviously one of my 4 types. So this is 7/5. The integral of e to the u is e to the u plus c. Plug back in, so I get 7/5 e to the x to the 5th, because that's what u is, plus c. And I'm all done. All right, so we're back again, and we're talking on 5.4, an integration on substitution. And what we want to talk about is how we can use the fundamental theorem of calculus to solve these types of integrals when we have limits of integration, when we have numbers here. So let's write down something here. So using the fundamental theorem of calculus. And let's just do an example of how this works with using substitution and the fundamental theorem to do a definite integral. So here are some examples. So use the fundamental theorem. I'm going to call this example 3. Let's continue on with the last lecture. The fundamental theorem of calculus to evaluate the following definite integrals, and that should not be capitalized, but it is. So part A, this is the integral from 0 to 1 of minus 2x e to the minus x squared dx. And this is not one of our 4 types. Okay, it's not a constant. It's not just a power of x. It's not just e to the x, and it's not 1 over x, so we can't integrate it. So we have to use substitution. So we're going to let u be equal to, and you have 2 choices, really, minus 2x or minus x squared. If you choose minus 2x, you would be wrong. But if you choose negative x squared, you'll be right. So the idea is you can let it be the thing on the inside. So if you realize that's the thing on the inside, let it be it. Or you'd say this is a function, and its derivative is right here. So when you take the derivative, du is equal to minus the 2 comes down, you get negative 2x dx. And so I can, plug back in over here. But before I plug back in over here, I need to change these limits of integration because these are really x stuff. And if I substitute back in, I change it to u stuff. So I have to change this 1 into u stuff. So the idea is u is a function of x. So u of 1 is equal to, you plug 1 into x, this is minus 1 squared, which is minus 1. And then if you plug in 0 for x, right, so you have u of 0, which is equal to minus 0 squared, which is equal to 0. Right, now, I can change my limits of integration. The lower limit is 0 still, but the upper limit becomes -1. And I have, let's change colors here. I have my u, right? This is my u, right here. So I have e to the u. And minus 2x dx, right? That's just right here. So that's my du. I can integrate e to the u. It's one of my 4 types, so it's just e to the u. I don't need to write plus c because it's a definite integral, so it goes from 0 to -1. And so I plug in the upper limit, which is e to the -1, and I subtract off, so minus e to the 0. And so that's equal to 1 over e minus 1. And that's my answer. Now remember, you can check these with your calculator by graphing this function here, this integrand, from 0 to 1, and then taking the integral, and you'll see that it will be equal to 1 over e minus 1. All right, let's do another one, part B. On this one, I have the integral from -1 to 0 of 1 divided by 1 minus 2x dx. And so I'm going to let u be equal to 1 minus 2x. Then du is going to equal a -2 dx. Right, remember the derivative constant is 0, and then the derivative of -2x is just minus 2, and I put the dx on the end. I'll have to change the limits of integration, so now use a function of x, so u of 0, so I plug in 0 for x. I get 1 minus 2 times 0, which is 1. And then u of -1, which this is equal to 1 minus 2 times -1, which equals 1 minus a -2. Okay? And that's equal to, of course, 1 plus 2, because negative is a plus, so that's equal to 3. And so this is going to be equal to, let's change colors. So it's going to be equal to the integral from 3 to 1 of what? Of this thing, right, which is my u. Great. So I'll have 1 over u. Then I have a problem, though, because I have dx, but over here I have -2 dx. But it's not really that big a deal because I can move over the -2 by dividing both sides by it. So this is du divided by -2 is equal to a dx. So this is du divided by -2. And so this is equal to then, this is equal to the integral from 3 to 1, and I'll pull out the 1 over -2. Right, 1 over u du. And I can integrate 1 over u. It's one of my 4 types. This is equal to minus 1 over 2 ln absolute value of u. I do not need to write plus c because it's a definite integral going from 3 to 1. I plug in the limits of integration, so I get minus 1/2 ln absolute value of 1 minus a minus 1/2 ln absolute value of not 1 but 3, because I plug in the lower limit here. So absolute value of 3. And now this term is 0 because ln of 1 is 0, and then minus a minus is a plus, so what I get is plus 1/2 ln of what? Ln of 3, because absolute value of 3 is just 3. Now remember, I could write this slightly differently. I could actually write this 1/2 times ln of 3 is the same as ln of square root of 3. Right, so watch out for little things like this, right? The power I can move up here, right? If I multiply, I can move the power up, so that's 3 to the 1/2, which is really square root of 3. But this is a fine answer. But if it's multiple choice, it might be hidden. The answer might be hidden by writing as ln of square root of 3. All right, so let's take a look at the group work. So take out the group work again and flip it to the back side of that handout and number 2 and try part A. All right, so on part A, you're given the integral from 0 to 1 of 2 divided by 1 plus x dx, and in the end you should get an answer of ln of 4. All right, so pause the video for a little bit and try to work this out and see if you can do what we did above. All right, so hopefully you got somewhere on this problem. So you have first to make your substitution, so u equals, right? This is not one of our 4 types, all right? So you have to make a substitution. You really only have one choice, 1 plus x. Then du is equal to dx. And you have to change your limits of integration. So if you plug in 1 for x, you get 1 plus 1, which equals 2. And then if you plug in 0 for x, you get 1 plus 0, which equals 1. And so now I'm going to make my substitution. So this is going to equal the integral from 1 to 2. 2 divided by u. Okay, remember my 1 plus x. That's right here. That's my u. And of course, dx is just du. And so this integral is now one of my 4 types. It's basically, if you want to, you got to rewrite this. If you want to, integral from 1 to 2, 1 over u du. And then I can integrate it. So this is equal to 2 times the integral of 1 over u is ln of absolute value of u from 1 to 2. And so I can plug in my limits of integration. So this is going to be equal to 2 times ln absolute value of 2 minus 2 times ln absolute value of 1, right, which is the same thing as 2 ln of 2 minus 2 ln of 1. And remember, ln of 1 is 0, so that term 0. And so this is just equal to 2 ln of 2, right, which is really the same thing as ln of 4, because you can take this number and write it on top. So 2 squared, so ln of 4. So both these answers are good. So 2 ln of 2 or ln of 4 is fine. Let's do the next one together. So in the next one, part B, we have the integral from 1 to e of ln of x cubed divided by x, and this is dx then. And we want to integrate this, so you're going to make a u substitution because, of course, it's not one of our 4 types. And you have 2 choices. You can let u be x, or you can let u be ln of x, the thing on the inside. And I want it to be ln of x. 1 is the thing on the inside, but the derivative of ln of x is actually 1 over x. So if you think about this, you can rewrite this and see that this is actually ln of x quantity cubed, right, times 1 over x dx. Right, we did this before. Remember, like if you have 3/4, you can write this as 3 times 1/4. It's the same thing. And now if u is ln of x, of course du is equal to 1 over x dx. Don't forget to change your limits of integration. So u of e is equal to ln of e, which equals 1. And then u of 1, that's the lower limit, is equal to ln of 1, which equals 0. So this is going to become the integral. Now the x stuff becomes the u stuff, so 0 to 1. This is my u, right, so ln of x here. That's my u. And then, of course, this 1 over x dx is my, right here, my du. So I have u cubed du, which equals u to the 4th divided by 4 from 0 to 1. So I plug in my limits of integration. So I plug in 1, so I get 1/4 minus when I plug in 0, which is 0 over 4, so that's just equal to 1/4. So 1 over 4 is my answer for part B. Now you should have enough to do the next homework assignment, integration by substitution, part 2.